example, situation is there are 30 students, and out of these 30 students, 5 of them will sit on these 5 chairs. So in how many ways they can sit? So the question is that in how many ways 5 of these students can sit in these 5 chairs. So this is the question. So we are using the formula NPR, and here n is equal to 30, the total number of items which are available to be shuffled, and how many of them we have to shuffle? 5 of them we have to shuffle in these 5 chairs. So that's why it will be r is equal to 5. So 30p5 in the calculator, we got this. These many possibilities are here. Okay, so this question, the same thing may be asked in different ways. Like there are total 30 plants and there are 5 plant pots. So in how many ways 5 of those plants can we put in these pots? So the solution will be the same, 30p5. Okay, so remember, I will write with a red star here, that where you will see that the items are distinct and where you will see, because sometimes in the question statement they don't describe that we have distinct objects or not. So we have to decide that they are distinct objects or not. So all living items are always distinct items. All living items are always distinct. Like the people, persons in the world, no two persons in the 8 billion population are same. Twins, some people say twins are same, but they are not same. They are two different. They have different masses, different sizes, different names. So all people are different. Similarly, all trees are also different. So all living items are always distinct. Okay, distinct means different. And if they are non-living, then according to the situation, we'll see that the non-living items, they are describing distinct or not. But for the living items, it doesn't need to be described about the distinction. Okay, so now basically, if you think in detail about this, when we are choosing NPR and R is smaller than N, so we are basically doing both the things. Like first we are selecting and then we are arranging. If you see this detail of the previous situation here, out of the 5 letters and 5 students, 5 distinct letters. We are first selecting 3 of them and then we are arranging those 3. So the permutation indirectly is doing first selection and then permutation, then arrangement, shuffling. Okay. So now I will give you a brief concept about the selection. And then you'll see that what is similar in selection and arrangement. So about the selection, we will do everything in detail later, but here just a brief introduction to everything I'm giving. So selection. So selection means that if we have n distinct objects, and r objects to be selected before it was to be arranged. So the formula to find the total number of selections. So all possible selections are possible number of selections will be equal to NCR. NCR, okay? N combination R. So C stands for combination. So if you see the main title of the lesson, it is permutation and combination. So now this combination is actually selection. So I will write here in bracket that this is selection. And permutation was arrangement. Okay. And in arrangement, what is important? Order of the objects matters. Order matters here. Like AB is a different arrangement than BA. So that's why we say that order matters here. And in selection, if there are three objects A, B, C, and we selected A and B, so either we select A and B or we select B and A, it is actually the same selection. So it will not be counted as two different selections. So here order doesn't matter. So the selection will be same, even if it's in different order. So here order does not matter. So now see that what does it mean that where order matters and why order doesn't matter. This coming back to that position here, this one, 5 distinct letters. So 3 of the letters we are to select and we are to arrange. So it was 5 letters, distinct letters are available. So 3 of them to be arranged, and one situation is that 3 of them to be selected. To be arranged. Okay. So these are the 2 different situations. Okay, so as I told that when we are doing arrangement, so first we select and then arrange. So see, ABC is the selection. So which I underline, these are actually the selections. These are total 10 selections. So we can say that this is, the answer of this is 10. And the answer of to be arranged, it means that after selection each time 6 ways to be arranged, so total 60. So this was 60. And this one we have done here, 60 different ways to arrange. Okay, so see that how we got this 10 without doing like this manually. If we see here, the formula is this. So for the example of A, B, C, D, E, 3 letters to be selected. So the word is selection. So it means NCR we will use here. So N is equal to 3, N is equal to 5, and CR is equal to 3. So it will be equal to 5C3. So if you use the calculator, then you will get, like in the calculator first you write 5 and then shift division mark. So you'll get C on the screen. After that you will write the value of R, 3, and then press equal, so you'll get it 10. And see here manually when we did, we also got it 10. Okay. So now see here we got 10. Now I will tell you the same thing, that what is actually NCR. As I told before, NPR. So if you see in this lesson, NPR is this one, that it is n factorial over n minus r factorial. So I will copy down this at the bottom and then we compare it with NCR, so that you will have the concept that what is the difference between NCR and NPR mathematically. Physically, you have found that it is only selection NCR and NPR. After selecting, you have to arrange them. So now the formula for NCR is NCR is equal to n factorial over n minus r factorial. Till here, both are similar, right? Only we have one more thing in the denominator, which is r factorial. So you will also use this in pure maths. There is a topic in pure maths which is called binomial expansion. So the application of this mathematical tool is also there. It will also be used in more parts of statistics later. Okay, so this is the formula for NCR, and the previous one was NPR. Okay, so I will write here that this is used for selection, and this is used for arrangement. And again I will write so that you remember that here order matters, which means AB is different than BA. And here order doesn't matter. So AB and BA will be the same selection, so it will be counted once. Okay, so this is the summary that when n distinct objects are given, so in how many ways we can arrange them, R of them arrange, and in how many ways R of them can be selected. Okay, now we will do one example, another example for the selection. So example. So we have 30 students in a class. 30 students, obviously these 13 will be distinct students, 13 students. So a team of 6 is needed out of these 30 students. So how many different teams are possible? How many different teams are possible? So first of all, you will think that is it arrangement or it is selection? Like order matters here or order doesn't matter? What is your opinion?
Order doesn't matter.
Order doesn't matter. Yes, correct. Because if let's say student number 1, 2, 3, 4 and 5 is selected, so either we select 5, 3, 4, 2, 1 or we select 1, 2, 3, 4, 5 or 3, 1, 2, 4, 5. In all the 3 selections we have the same students. It means it will be considered as one selection. So here order doesn't matter, it is actually selection. So it means that we'll use NCR here, not NPR. Okay, so after deciding that this is NCR selection, so now we'll see that what is N and what is R. So N is equal to available students and R, how many of them we need in the team? 6. So it means it will be 30 C6. So these many teams are possible with these 30 students. So if you use the calculator, 30 C6, so it's a lot lot of possible teams are there. 5, 9, 3, 7, 7, 5, right? So 0.59 million, more than 0.9, almost 0.6 million teams are possible with only 30 students. And if we can do manually, so we can do like this one. This is the manual way. But it will take time if you write all the 30 letters or 30 symbols, and then you will shuffle them. So no need to do that. So because mathematics is helping us in such situations. So 30 students, 6-member team. 6 members we usually have in basketball. 5 players are in the basketball. And if we want to select a football team of 12 players, right? So then 30C12. So 30C12, if you use the calculator, 30 combination 12, so it will be so many teams. 864 93225. See, these are more than the basketball teams. Because here we are taking only 6 students. There we are taking 12 students. So for football team, of 12 players, we need 30C12, and so 30C12 is 8, 6, 4, 9, 3, 2, 2, 5. 86 million. Okay. These are around 86 times more than this. Not 86, more than around 160 times more than this. Okay. Is it clear? So manually we cannot do. So only using these formulae we can find the
Yes, sir.
ways. So these many teams are possible. Okay. Now if I extend one more part using the same example and same concept, in this example, say this is part A, this is part B,